Alright guys, welcome to another tutorial, and this is about the Interpolation class in LibGDX and how to write such a test like this one here. Woo! Woo! Graph, example, duration, stuff, okay? And we got that thanks to Xes Garcia and Manu Iveco. I don't know how to pronounce these names, I'm sorry, but they requested an explanation of the interpolation sample on the LibGDX source. And, well, I could just go ahead and explain it, but like I already did one time, let's just rewrite it and we'll totally know what's going on. So, well, I just showed you that this is what we got already. We have a list on the left with all the interpolation names, and, well, this one's pretty funny. Then we have when we click them, we get this time marker here going on, and we see, yeah, we can move this point around as well. We can also change the duration, and, well, that's all just pretty basic stuff. Okay, I'm sorry. So, let's get ahead and actually, go ahead and actually create this for ourselves. So the problem is, we're not really done already, we have to start again. So, there we go, and we actually just got this. We got the list on the left, but that's about it. There's nothing going on what actually is supposed to go on. So this is the source for the nothing going on screen that you just had. It's just a stage, a skin, and a table, pretty basic. Here we set the input processor and create the stage, we create the table and the skin, and add the list to a scroll pane, which we add to the table, which we add to the stage. And then this stuff is acted and rendered and resized and disposed and actually disposed and all that stuff that you already know. Just this string array here is probably something to talk about. Well, it's just a normal string array with all the interpolation names, which I just copied from the original test. So you can go ahead and actually, yeah, write them out yourself, but that wouldn't really make much sense. So whatever, let's go ahead and actually get the graph in the center going. So what do we need to draw this graph? Pretty obvious, a shape renderer, because we want to render some various shapes, mostly lines. Actually, almost only lines. So let's go ahead and instantiate this shape renderer and make sure it's disposed and make sure it's resized. And actually, how do we do that? Well, we can just set the projection matrix to the one of the camera of the stage, because they are both having the same kind of viewport. So let's just reuse the stage's camera. Stage.getCamera and the combined matrix of that. But here we say stage.setViewport, so it should actually be fine, but the setViewport doesn't already update the camera. So all we have to do is to say we want to get the camera off the stage and update that manually. So when we set the projection matrix to the renderer here, that's already calculated all correctly. So now we're ready to draw stuff using our newly created shape renderer. Let's just go ahead and start by drawing the simple graph in the middle of the screen. So we want to begin rendering with a shape type line and end rendering, well, with whatever. Now we actually need to have some information about the graph, because we cannot just draw a graph that we know nothing about. The first thing we have to know is the size. And I'm just going to say this is 400 pixels, because, yeah, because this is 400 pixels. Any questions? Okay. And then we'll just go ahead and say renderer.rect for rectangle, and we have to give it the x, y, width, and height. I guess we want this thing rendered in the center of the screen, so let's just go ahead and calculate the x, y, width, and height so that the thing is going to be drawn in the center of the screen. The x and y are the bottom left, not like, well, yeah, actually like anything else. It's the bottom left. So let's just go ahead and say we create a float bottom left x and bottom left y. So all that we have to do then is say bottom left x, bottom left y. The width is the graph size, and the height is the graph size as well, because, well, it's a rectangle with all sides the same size. Okay. Bottom left x and bottom left y are not initialized yet. That's correct, Eclipse. Good job. That's because we have to calculate them. So we wanted this to be in the center of the screen, so it's natural to say gdx.graphics.getWidth divided by 2. But since this graph is a rectangle and not just a point, we have to subtract its half width, which is the graph size. The same for bottom left y. Equals gdx.graphics.getHeight divided by 2 minus graph. I can type this word. Minus divided by 2. Okay, so I hope this looks alright to you and alright to the actual test. Let's see what happens. Yep, we get this nice little rectangle rendered on the screen. Okay. Well, that's pretty boring. Let's start to actually draw such, well, the actual graph in here, not just the graph's bounce. Oh my god, I can't talk today again. Well, I haven't all day, so okay. Let's comment this at draw graph bounce. Pretty simple. And then draw graph. Yeah, the actual graph. So how do we draw the graph? We want to use the function renderer.line and give this an x and a y and another x and a y. So these are the previous, well, basically for the function, they are the 2 points between which a line should be drawn. And we want to draw a line from the previous x to the next x. So that's just how you do in school. Draw the points and connect them using your ruler. That's what we do with the renderer.line. So we actually have to know the previous x and next x into in this whole graph, and for that we'll probably use a for loop. So int step, well, yeah, okay, int step equals 0. Step is smaller than graph size and step plus plus. So we're stepping all over the graph size. We could also call that x, but we want to use that variable name for something else. Actually, we could say we want to say it's smaller than steps, and we'll create another float up here, call it steps, and we could just set that to graph size. But do you really think it's necessary to go ahead and draw all the 400 points? I mean, if you're in school, you wouldn't also just go ahead and draw every single x that you can possibly draw onto your paper. It's probably enough to draw a few points and then just connect them with lines. So let's say we divide this by 2 or even by 4. It doesn't matter. We'll just choose 2. So we don't have to calculate as much as well. Yeah. Okay. I don't like red font down there. Thanks. So now we are just going over all these steps here in the well, on the x-axis of the graph. Now we just have to figure out, well, at first we have to figure out the x, but that's pretty simple. X is the bottom left x plus step. So why is that? We don't have to just take the actual function coordinates, but we have to draw this thing on the screen. So we have to just add the bottom left x and to that the step. So if step was 50, we would draw from the graph position plus 50, so 50 on the graph. That's pretty simple. But it's not as simple with y, because that's the bottom left y plus step as well. For a linear interpolation, for a linear function that just goes from the bottom left to the top right, it's pretty simple, as you can see. Then we want to render the line. Well, he's already guessing it, but we have something of our own for this. And actually, like I just said, we need to know the previous ones and the current ones. So these are going to be x and y, and these are going to be last x and last y. So now what's last x and last y? Yep, it doesn't exist. So let's go ahead and say last x equals bottom left x. So just to start off at the bottom left corner. And last y equals bottom left y. And then we have to always update the last x and last y to, well, the current one, which in the next step is the previous one, if that makes any sense to you. I hope it does. This should already be enough to actually draw this thing on the screen, if I remember correctly. And well, kind of. Because, well, have a look up here. I said steps equals graph size divided by 2. So it just gets to, well, the center of the graph, because that's the graph size divided by 2. To fix this, we are going to use relativity, or whatever you want to call it. For this, we want to figure out at how many percent of the whole graph size is this step. So this is, well, pretty simple. We just have to say step divided by steps, and we'll know how many percent of steps is that step. And then we can say we don't want to add the pure step to it, but we want to take the whole graph size and multiply that by percent, because whole graph size by, let's say, 50%, if step is 50% of steps, makes the half graph size, and not just like it previously was. The same here, so graph size times percent. Right? Right. And there we go, it suddenly draws all over the place. Okay, so that's linear. So we actually would have to choose this one here, that's this one, linear. But, well, we want to get all these others as well. They look awesome, we want to find out what they do. So we have to actually use interpolation. Let's just quickly do this without regarding what's selected in the list. And let's just say we want to select this bounce out here. And the following would happen. Now you have to know about the interpolation class. It's pretty simple to use, so don't worry. We can just say interpolation dot to assess all these interpolation fields here that have been statically initialized. Select our bounce out one and say apply. So what do we want to apply? We want to apply the percent. So what does this apply actually do? It takes the percent and interpolates it. So this is from 0 to 1, and the interpolation bounce out apply method says, well, 50% on this bounce out interpolation are actually just, I don't know, 30%. And later then it quickly raises to 70% or whatever. That's what an interpolation does. So we just take that. And, ooh, what do we got there? We got this, well, interpolation applied here, but it still doesn't care about what we select in the list on the left here. So that's already the basic explanation of how this whole thing is working. The rest is basically just extra features. But since this test is pretty boring without these extra features, let's add a few. And how long is this recording already? Okay, that's pretty. Damn, I didn't check the time in the beginning, but let's get going. Actually, I'll cut this here and maybe cut it together again later. But whatever, thanks for watching the first part. And yeah, I'm going to see you in the second one where we add all the extra fancy stuff. Bye!